Hey everyone! Today we're going to continue on with our chemistry review and understanding some of the information that we went through last year and some that we'll carry into this year. So let's go ahead and get started. So we left off with talking about ions, and now we're going to get into more of the compounds. And first we have to understand the difference between ionic and molecular compounds. Ionic compounds are composed of cations and anions. So this means generally it's going to form between a metal, which is our cation, and some kind of nonmetal or metalloid, which is our anion. And what happens is the charges from these ions cross each other and simplify in order to create a compound. And we're going to do this on another slide. Molecular compounds are not composed of ions, so that means they shouldn't have polyatomics in them at all. Instead, they are composed of molecules. Generally, we say they are made up of two or more nonmetals, and that can also include metalloids as well. But absolutely no metals whatsoever. So if you see a metal, that's ionic. So here we're going to look at the difference between ionic versus molecular. So, one, it's ionic if it's a metal. If there are no metals, it's going to be molecular. So you have to ask yourself, here, potassium, is it a metal or a non-metal? Here we know that potassium is a metal, so this is ionic. Looking over here, lithium. Lithium is on the left side of that table, so it is a metal, so it's ionic. But if I look at phosphorus, phosphorus is to the right of the metalloids, so that is going to be considered a nonmetal. Chlorine is also considered a nonmetal, so this is molecular. So I want you to pause the video and see how much more of these that you guys can do, and then unpause it and see if you got them right. Okay, let's see how you guys did. Here on this compound, both chlorine and oxygen are nonmetals, so this is going to be molecular. Nitrogen and bromine are both nonmetals, so that's molecular. Here, though, iron is a metal. This makes this ionic. Sodium is a metal, so it's ionic. Sulfur and nitrogen are both nonmetals. They're to the right of those metalloids, so this is going to be molecular. And then the last two are also molecular because sulfur and oxygen are nonmetals. Now, when it comes to creating ionic compounds, we have to remember to cross our charges and reduce. So here I've posted several pictures of examples of how we cross our charges. This is why it's important for us to go over what charges are, and that's what we did in the last lesson. So here we have calcium, has a 2+ charge because it's in group 2. Sulfur has a 2 negative charge because it's in group 6. And what we do is we cross them down. So the 2 from sulfur comes down on calcium and vice versa. And then we have to reduce this. So these 2's cancel to become CaS. Over here, iron has a 3+ charge, and that was given to us. Oxygen has a 2 negative. So what happens is this 2 gets thrown down here on the iron. This 3 is crossed over and put down here on the other side of the oxygen. And these compounds cannot reduce. Looking in the bottom left, here we're working with polyatomics. Calcium has a 2+, while nitrate has a 1-. So what we're going to do is we're going to take that 1- and cross it down. Since it's a 1, you don't have to write it. Here, the 2 from the calcium is going to go down on the nitrate. Now, remember, if you cross on a polyatomic, you have to make sure you include parentheses. So this 2 will go to both nitrogen and oxygen. And then over here on the right, we have a crossing on a polyatomic, but we're crossing a 1 and we don't have to write it. So we don't have to put it in parentheses. So what we're going to do is we're going to determine the element's charges and then cross them to determine the compound that they would make. I'm going to do the first 2, and then I'm going to have you guys try the last 2. So here, if I'm looking at number 1, magnesium is an element. So I'm going to put Mg. It is in group 2A. So I have to lose my 2 electrons that I have. I can't try to gain 6 to get to 8. So if I'm losing 2, I get a 2 plus charge. Chlorine is Cl. It's in group 7, so hopefully based on yesterday's lesson, you should know that's a -1. And then I have to make sure I cross them. A 1 will go down on magnesium. Chlorine will get the 2 crossed down on it. So MgCl2. When we have a Roman numeral, that Roman numeral tells me my charge. So here, copper has a 2 plus charge. And then this one says hydroxide. Hydroxide's not an element. It's actually a polyatomic. So here we have to look on our chart. It's an OH negative. And I have to come over here and cross it. When I look at my Cu, a 1 is crossed down on it and you don't have to write it. However, on my OH, I'm going to cross down this 2, but this is a polyatomic, so I have to make sure I put parentheses around it, followed it by a 2. So what I want you to do is kind of pause this video and see how you guys do on the next 2. Okay, so hopefully you guys did okay. Let's check your answers. Ammonium is a polyatomic. It's an NH4 plus 1. Bromine is an element with a -1 charge. So when you cross them, nothing comes down on this NH4 except for a 1. And when you write bromine, the only thing that comes down is a 1 as well. So you can just write it as such. On 4, aluminum has a 3 plus charge and nitrogen has a 3 negative. So when we cross them, originally aluminum gets the 3 from nitrogen. Nitrogen also gets a 3 from aluminum, but we have to make sure that we reduce, so a 3 and a 3 will reduce to aluminum nitride. Now with this chapter, we also have to learn how to split them apart in order to figure out their charges. And this is going to become super important in the solutions chapter. So let's go ahead and get to working on this. First and foremost, if it is a number that's attached to a polyatomic, we absolutely cannot touch it. So we have to ask ourselves, here, let's uncross. There's no number down here, so if I uncross it, chlorine has a -1. Here, this 3 here is attached to a regular element, so I can actually undo that. Fe has a 3 plus, and then check it. Yeah, chlorine has a -1 on the periodic table, so it makes sense why iron is a 3 plus. Looking down here, we can uncross it. When we uncross it, lithium appears to have a +1. Phosphorus gets a 3 negative. Yeah, that makes sense. Lithium's part of group 1 and phosphorus is part of group 5. Then when we get down here to PBS, we uncross it. PB appears to have a +1. S has a -1. And you might tell yourself, whoa, whoa, whoa. Sulfur's in group 6, so sulfur should be a -2. So what happened was this was most likely reduced, and PB is actually a +2 to get reduced. So these are the 2 that we're looking for. So let's go ahead and learn a couple others. Here we have aluminum oxide. So if we uncross it, oxygen typically has a 2 negative. Aluminum has a 3 plus. Yep, this checks out. Oxygen's in group 6. Where people run into trouble is something like number 5. So in number 5, if you uncross it, Be, a lot of people want to say it's 4 plus, but what it's attached to isn't just a single element. So we have to recognize that, oh, that's a polyatomic. I can't move that 4, so beryllium has a +1. SO4, if you uncross it, has a -1. If you consult your polyatomic chart, you're going to be like, no, no, no. This should be a -2, which means beryllium should be a +2. Also, beryllium belongs in the alkaline earth metals, which is group 2A, so it makes sense with this +2. Down here, we can uncross, and we can uncross this one because it's outside the parentheses. So it's saying tin has a 4 plus. Hydroxide, there's nothing written here, so it's an understood 1. And when you check the polyatomic chart, yes, that is an understood 1. When you get down here, we can still uncross. So uncross here and uncross here. Magnesium gets that 2. Phosphite gets the 3. When you check it, phosphite is a 3 negative and magnesium is in group 2. So that checks out as well. And then the very last one, when we uncross from down here on carbonate, we can't move that 3 because it's part of carbonate. There's 2 elements there. So it's an understood 1 in H4, understood 1. And then our CO3, our carbonate, actually gets this 2 uncrossed because it's outside the parentheses. When you check the polyatomic chart, yes, that is what they are read as. Now, in terms of naming ionic compounds, the first thing we have to do is write the name of your cation or your positive element first. If for some reason that first element has more than one charge, a Roman numeral is required, and you figure out the Roman numeral by uncrossing and checking it like we were doing on the last slide. These elements that require a Roman numeral are things like chromium, manganese, iron, cobalt, copper, mercury, tin, lead, gold, and nickel. Then, after you get the first one written, you write the name of the second element. If it is something from the periodic table, it ends in "ide." If it's a polyatomic, you name it based on the chart, and their names usually end in "ate" or "ite." So here's a couple examples. So here, if we're working through these, I'm looking at the first one. I name the first element iron. This is a transition metal, so we have to figure out what its charge, and we can do that by uncrossing it. So iron 3, and then we have chlorine, and it's an element on the periodic table, so it becomes chloride. On this one, we can name it as we see it. Here we have lithium, and then it's not a transition metal, so I don't have to worry about Roman numeral. And then I named the next one phosphorus. Remember, we changed the ending to "ide," phosphide. Here, we're going to name the first element lead, and I have to uncross my charges and check them. So here, this is an understood +1. Sulfur is a plus or a -1. When you check the periodic table, you're like, nope, sulfur has to be a -2 because of the group. That means lead was a +2. Then we can put the Roman numeral as lead 2, and then sulfur becomes sulfide. So I want you to kind of pause this video and try to name the rest of them and see how you did. Okay, let's go through these. Here, aluminum is just aluminum because it's not part of the group. Oxygen becomes oxide. Over here, Be is beryllium. It's not a transition metal, so I can leave as is. And then SO4 is sulfate, and of course you leave that as is as well. Here we have Sn, which is tin. This is part of my one that requires more than one, so I need to uncross it. Hydroxide got a -1. Tin has a +4. Yep, hydroxide's a -1, so I can say tin for hydroxide. Down here, if you uncross them, actually you don't even need to, you can just name it as is. Here you have magnesium. It's not part of your list. And then PO3 is phosphite. And then the last one, NH4, is ammonium. And then CO3 is carbonate. This leads into naming and looking at molecular compounds. So remember, molecular compounds have no metals, and we have no ions either. Typically, we're working with all nonmetals, and so naming them are a lot simpler. You want to write the name of the element in the order that's listed in the formula. So whichever element is first, you write that first. And all we do is use prefixes to indicate the number of each atom. So if you have one of them, you write mono, two, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. The only time you don't have to use a prefix is on the first one, you don't have to use mono. Now, in terms of naming the second element, we always change the ending to "ide." So let's do a couple examples. Here, this is nitrogen. My number is 2, so the number for that is dinitrogen. And then here I have oxygen. Now remember, I only have one of them, so I have ma, nox, and my ending changes to "ide." Here I have P4I10. So here 4 is tetra, P is phosphorus, 10 is deca, and then I is iodine, but remember you change the ending to IDE, iodide. Here I have phosphorus. There's only one of them, so you don't have to write mono on the first one. It's just phosphorus. And then here on the second one, I have 3 of them, so remember tri. This is chlorine and gets changed to chloride. And then last but not least, sulfur. Since it's just one, I don't have to write the mono, but I do on the second element. So this is monoxide for this one. And you can work backwards as well. So here I can see tetra means 4, phosphorus means P, so 4 phosphorus. Sulfide is sulfur, and tri means that there's 3 of them. So I want you to pause the video and try to complete the rest. Okay. Hopefully you guys got them right. Here I have sulfur, di means I have 2 of them. I have chlorine, di means I also have 2. Over here, nitrogen, there's no prefix, so there's only 1. We have fluoride, which is fluorine, and tri means there's 3 of them. And then over here, sulfur by itself. Then we have oxygen, but di means there's 2 of them. Okay. So what I'm actually going to do is I'm going to actually stop right there because naming was a little bit confusing for some people. And so I want to make sure that you guys formally understand that because naming is going to be an advanced chem. If you have questions or you need more practice, please let me know. But I'm just going to go ahead and stop my video right there. And otherwise that, I hope you guys have a great day.